Welcome to grade 11 chemistry.
In this video, we will discuss about lattice energy and bond energy. We have learned that formation of a chemical bond is possible only if there is a fall in potential energy of the system. Lattice energy is regarding ionic compounds, whereas bond energy is regarding covalent compounds. Ionic compounds are formed by transfer of electrons, whereas covalent compounds are formed by sharing of a pair of electrons. For example, sodium chloride and covalent compounds, hydrogen, oxygen, etc. Lattice energy is in the formation of compounds, whereas bond energy is related to breaking of compounds. The energy is released regarding lattice energy, whereas energy is required in bond energy. As energy is released to the surrounding, it is exothermic, whereas energy is absorbed or required for the reaction, it is endothermic. This is shown here. A plus and B minus ions form the compound AB, releasing energy. For example, sodium ion in the gaseous phase and chloride ion in the gaseous phase, forming sodium chloride, releasing 778 kilojoules per mole. Whereas in bond energy, the compound AB absorb bond energy and break to the ions. So bond energy is defined as the amount of energy required to break bonds in 1 mole of gaseous covalent substance to form products in the gaseous state. The hydrogen in the gaseous phase absorb 436 kilojoules per mole, forming the products in the gaseous phase. Whereas lattice energy is the amount of energy released when 1 mole of a solid ionic compound is formed from gaseous ions. The sodium ion in the gaseous phase react with the chloride ion in the gaseous phase, forming sodium chloride, releasing 778 kilojoules per mole. In both cases, the energy required or released is expressed in kilojoules per mole. Higher the lattice energy, greater is the tendency to form ionic bond. And here also in bond energy is a measure of strength of the bond. Higher the bond energy, greater is the strength of the bond.
Now let us discuss the factors
That affect lattice energy and bond energy. Number 1, charge. Higher the charge, greater the lattice energy. The lattice energy is directly proportional to the product of the charges Q1 and Q2 and inversely proportional to the distance between the ions. So higher the charges, greater lattice energy. And smaller the size, greater lattice energy. As lattice energy is inversely proportional to the distance between the ions, higher the size, smaller will be lattice energy. Which ionic compound has high lattice energy? Sodium chloride or magnesium oxide? Magnesium oxide has magnesium plus 2 ions and oxide ions, oxygen minus 2 ions. Whereas sodium chloride has sodium plus ion and chloride ion. As magnesium oxide contains plus 2 and minus 2, magnesium oxide has higher lattice energy. The factors that affect the bond energy are the size of the atoms. Similar to lattice energy, bond energy is inversely proportional to size of the atom. Higher the size, smaller will be lattice energy, or smaller the size, higher will be lattice energy. The second factor is multiplicity of bonds. Bond energy is directly proportional to multiplicity of bonds. For example, carbon-nitrogen triple bond, carbon-nitrogen double bond, and carbon-nitrogen single bond. This bond will have more bond energy than double bond or single bonds.
Let us see some facts about bond
Energy and bond dissociation energy. We have defined bond energy. Bond energy is the amount of energy needed to break bonds in 1 mole of a gaseous covalent substance to form products in the gaseous state. So bond energy can be considered as average amount of energy needed to break down all the bonds between same two type of atoms in a compound. Whereas bond dissociation energy is the amount of energy needed to break down between atoms of a gaseous homonuclear molecule. Bond dissociation energy is related to homonuclear molecule, whereas bond energy is the average amount of energy to break down all the bonds in a compound. In the case of bond energy, the value will be different from one bond to another. Whereas bond dissociation energy, the value will be the same. Bond energy is regarding polyatomic molecules, whereas bond dissociation energy is regarding diatomic molecules. So bond energy is the average of two different bond dissociation energy. Thank you.